Okay, now actually doing the problem, finding the derivative. So the original problem was this. Notice the x is not inside the radical. This is just a coefficient. And so the derivative of a coefficient times x is the coefficient. Then we get the 2. The 2 is the coefficient also, but it's times the cosine. I do not need a product rule in this case. So the 2 just hangs out, derivative of cosine minus sine. And so I've got square root of 3 minus 2 sine x. So there's my derivative. So there's step 1. Step 2. Set that derivative equal to 0. And step 3, solve that. Trig equation. Your basic trig equation, what you want to do is first solve for the trig function. So moving that square root of 3 to the other side. And then solve for the trig function. And we get sine x equals square root of 3 over 2. Then again, it's about knowing that basic trigonometry that you're supposed to have brought to the class. And so what we're asking ourselves here, on 0 to 2 pi, because that's what it gave us up at the top, on 0 to 2 pi, where does sine x equal square root of 3 over 2? And you just have to have those values very well memorized. There's no way else around it. And I would ask a classroom full of people here, if we had a classroom full of people, but we don't, that sine is equal to square root of 3 over 2 at pi over 3. That's where it is in the first quadrant. And then sine is the same thing if you do the unit circle. Sine is the y coordinate on all those points on the unit circle. And so sine is positive. Being the y coordinate, it's positive in the first and second quadrants. So here's our angle in the first quadrant. In the second quadrant, it's 2 pi over 3. And then that's actually the answer here. It says find the equations. Well, the equations are x equal pi over 3, x equal 2 pi over 3. They didn't ask for the points. They just wanted those equations. Now, I can check this. That remember, the horizontal tangents are predicting the high and low points. So I'm going to graph the original function. And so the original function, get rid of the stuff that we just did, clear, and clear. Clear it. There we go. So it was square root of 3 x, and then it was plus 2 cosine x. So I'm just graphing the original function because what my horizontal tangents are predicting is those high and low points. And it said 0 to 2 pi, so let's hit the window and let's go from 0 to 2 pi. And my answers came out to be pi over 3 and 2 pi over 3. So let's count by pi over 3. And I don't really have any information about the y's, so I'll leave the y's alone. Maybe we'll play around with the y's after we see the initial picture. But I put in the original function. Then they said go from 0 to 2 pi, so I put that in there. And then because my answers turned out to be pi over 3 and 2 pi over 3, I'm going to count by pi over 3, and that's what the x scale means. What are you counting by? After we get all that in there, let's hit graph. So there's the sine curve. And not a great picture. So let's get a better picture. I don't need all that blank space on the y coordinate. And so let's hit window again. Instead of going all the way down to -10, let's just go to -1 and graph that. a great picture. We're trying to check the numbers. And so we're going, our answers came out to be pi over 3 and 2 pi over 3. Now, I graphed it all the way to 2 pi, but there really was no reason to graph it all the way to 2 pi because the answers I'm checking are pi over 3 and 2 pi. So let's graph it again, going just to pi, because the stuff I'm checking is pi and 2 pi over 3. Or the stuff I'm checking is pi over 3 and 2 pi over 3. So instead of graphing all the way to 2 pi, which is what the original problem kind of suggested, my answer is pi over 3, 2 pi over 3. I'm going to graph to pi. So I'll graph it again. And gosh, that didn't look much better. But now I've got a lot of blank space on the top. So let's try the window one more time. Instead of going all the way up to 10, let's try just going to 5. And let's graph that. And now we're getting a little bit better, but still not great. So next thing I'm going to do, I'm going to give up seeing that x-axis. And so I'm going to really graph it just between, it looks like if I graphed it just between 1 and 4, I'd see a good picture on the y-axis. So I'm going to really zero in on this strip right here. And so all I'm showing here is just, if you got enough time to play around with the graph, playing around with it till we see a good picture. So I'm going to really zero in on that strip right there. And this time on the y-axis, I'm just going to graph it from 1 to 4. And let's see what we get there. And now I really am starting to see a little bit more. I see a high point right there, a low point right there. Trace. Pi over 3. Pi divided by 3. I think that should be this high point right there. Enter. Indeed, that's that high point. So I think that's right. Then this low point right here, I think that should be the 2 pi over 3. So trace 2 pi divided by 3, enter. And indeed, that goes to that low point, and our answers were right. Now, it took a while to get a picture that really showed us the answers, but the point was that we can check these things looking at the picture. Now, you would have never guessed the answers from the picture, because remember, you don't give me decimals unless I give you decimals. They're the answers. But once I have the answers, I can use the calculator to verify my answers. Okay, last problem in this section, and then this section will be done. Same thing, find the equations for the horizontal tangents on the interval 0 to 2 pi. So same steps. 1, find y prime. So y prime is going to be 2 plus cosine x. 2, set y prime equal to 0. So we've got 2 plus cosine x equal to 0. 3, solve. So 2 plus cosine x equals 0. Cosine x equals negative 2. And so then again, you're asking yourself, on 0 to 2 pi, where does cosine x equal negative 2? And I would ask the class, and people would stare at me, and then finally someone would tell me, nowhere. Recall the graph of y equals cosine x looks something like this. That it starts at 1, goes to 0, goes to negative 1, back to 1. And same thing that way. That's 1 and that's negative 1. Cosine x never equals 0. I mean, cosine x never equals negative 2. Cosine x is never negative 2. The range of cosine x is negative 1 to 1, so it's never negative 2. And so this has no solution. It doesn't have any horizontal tangents. And that's going to check by looking at a picture too. I put the original problem in there, 2x plus sine x. So there's the original function. And let's just do a window of 0 to 2 pi. And then let's just go back to, say, negative 10 to 10 on this one for the y's. Graph it. And it just seems to be going up, 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 getting a little bit better because it kind of runs off the edge there. So let's do the window and let's go, and we had a lot of blank space below the y-axis, so we'll go negative 1 and we'll just guess, 16. Graph that. There's the original function, and we said that there were going to be no horizontal tangents, which means no high and low points, and indeed no high or low points. So this too checks. There is no solution. And that is the end of this section.